In this session, we briefly discuss the motivation of the course, addressed to provide a basic understanding of theoretical background before being involved in point-to-point radio link design. Marconi's first experiments for transmission and reception of electromagnetic signals were carried out in the last years of the 19th century and at the beginning of the 20th century. The success of these experiments marked the beginning of the new era of wireless communications. Since then, a number of developments were carried out in the field of both mobile and fixed radio communications. In particular, starting at around the middle of the 20th century, point-to-point radio links at frequencies slightly below or above 1 GHz succeeded as a practical solution to set up long-distance communication networks. Today, even in the era of fiber optics networks, point-to-point radio systems are still a successful option in many application areas. The interesting and challenging aspect of link design is that the radio engineer must meet performance objectives while facing variable climatic and environmental conditions. Each radio hop shows peculiar characteristics relating to the terrain, the climate, and the interference environment. In a point-to-point radio link, propagation of electromagnetic waves is affected by a number of phenomena produced by the interaction with the atmosphere and the ground. Physical laws governing the propagation of electromagnetic waves are given by Maxwell equations. However, they are not directly applicable as a general rule in such complex conditions, unless the overall environment is defined in detail and it is very simple. Field experiments and in-service observation of radio link performance are interpreted on the basis of basic theoretical physics and allow to refine propagation models useful to the radio engineer. By the way, we wish to clarify that the words radio and radio wave will be used in this course referring to communications through electromagnetic wave transmission in a wide range of frequencies. In most cases, the word microwave could have been more appropriate. However, we preferred the use of radio as a simpler and more general term. From a practical point of view, propagation models can be selected as a trade-off among design requirements, computational load, possibility of detailed environment description, cost, time effort, etc. Obviously, model reliability is a fundamental requirement. Significant aspects are the source, the widespread use, and experience gained over a number of years. To this goal, reference is mainly made to widely used models, like the ones proposed by international authorities. The process is now clear. Propagation models are selected, covering all the various impairments in radio wave transmission, like atmospheric refraction, ground obstruction and reflection, rain, multipath, etc. They are assembled in a software design tool, thus leading to implement the complete design process. After this brief introduction, it is obvious that the use of a reliable and effective software tool for the design of a radio link is a must for the radio engineer. However, the question can now be raised: is the software design tool the definitive and sufficient answer? Well, in a paradoxical representation, a computer session can be something like this. It is evident that a software design tool cannot be used like this, just a frenetic sequence of data input and button clicks. The radio link design can be effectively carried out only if the radio engineer is able to have full control of the design process. This includes evaluation of design assumptions and a well-informed selection of models and model options, as well as analysis of intermediate results and design trade-offs. Finally, evaluation of result sensitivity to input data or environment modifications. The motivation of this course is to provide you with a basic understanding of theoretical background in point-to-point radio link design and to take the maximum benefit from use of a software design tool for radio link design. Fine, let's start from the very beginning.